So I've been able to line this up nicely. This is a nice 4mm hole once again, just carefully biting it in. Of course, this is between two clamped pieces of perspex, so I need to go gently with this as we drop it through. Don't put your fingers on the drill like I just did, please. It's pretty safe. So once again, I'm lining this up in the vise, getting that nicely done. I've actually leveled the top. You can't quite see that because when you can see it sort of here, although it's a bit blurry, that the very first touch with the center drill is on a flat spot. And now once again I'm just going to, I hope this clears up. Doesn't look like it is, never mind. So once again just drilling that through nicely so that I've got the beginning of the hole where I'm going to use the sheath for the brass. It seems to be really focusing on my trays. Now there we go, screwing this. I've screwed this together. Now I'm just unscrewing it and you can see that the holes are nicely shared between the two slices of perspex. That's exactly what I wanted. So now comes the tricky part, which is to make a pathway for the brake wire. Now, I was thinking for a while about how to do this, and sometimes you can overthink things. This is simply using the parting tool and using it carefully to make the pathway for the brake wire. This worked really well. Got to say though, you need to do it with some care because it cuts very quickly. But the good thing about using a disc like this is that it gives you a sense of continuity. It makes this really quite smooth, or the arc quite smooth, assists with that. Now just trying some wire in that, and clearly it's still a bit proud, so we'll go down a bit further. Now what I'm doing is the same routine on the 3mm piece of perspex, and I will cut that out now as well. Screwing it on. That moves nice and freely, which is exactly what I want. So this is step one done. Now I have this now all together, and I'm going to now have to build a slot for the arm in the middle. I'm going to put the arm horizontal for now. I can always change that later. It might have to end up being vertically down. It depends where the servos are going to go, but right now. So I'm using my 5mm mill here, and I'm just holding it level with the arm on the pedestal drill. I'm just taking a series of, it's probably 2 or 3mm cuts, because this is 9mm deep. Now I'm down to the final cut, and I've got it fully through, and just machining that out. I'm telling you now, this is not easy. This is a bit springy. But that isn't too bad, is it? That's basically what I want on there. That's moving quite nicely, and the sleeves are holding those arms nicely at the end. I just have to trim them down now so that they fit into the servos. So now I'm putting the whole thing up into the hull, and this is going to be a bit of a process. Now, as I said to you, it was too short, and I'm remaking it. And I use the end pieces again, but basically most of it is new. So I've got it in now, and they're being held, and you can see that these arms are now turning as I turn the lever inside. But they're all over the place, naturally enough, because they're not being held by anything. But that's okay. Gives you a bit of a sense of what they're going to be like. All right, where are we up to? This has been probably the most challenging mechanical challenge that I've had. As you can see, we've made this, which now fits into the bow, holds the wire. I can turn it. I'm going to put some lubricant in there to help it work a little better and ease some of these out a little bit, just to make it work as well as I can. The hydroplane, as well as you can see that, because it's clear, that fits on quite nicely. It's very interesting. If you look at this animation at the moment, which is on a movie that they made about the Nautilus, it shows it underwater with the front planes shut like this. I put this on a chat room and just said, what do you make of this? And the experienced guys all came back and said, well, that's a crap animation. It's really quite funny because it had to be out. And how would you, at what stage would you bring them in and when would you open them out? So consequently, someone's made this animation. They've made this wonderful doco all about the Nautilus, and someone with knowledge would have thought, well, that's shit, that doesn't work. And then someone else would have said, yeah, but we're not going to redo it. Funny, isn't it? Anyway, problem is this. The bow of the boat looks a bit like that. The hydroplanes are sitting on the part that's beginning to move in. I've been able to think through how to do this from the perspective of that angle, but I can only make these work like that. I can't twist them again. So consequently, the hydroplanes are sitting a little bit out in the front, and when they fold up, they're not going to be neat like that nice little animation. Oh, I can live with that. That's all right. Okay, now what we haven't achieved yet is to think about the servos. Now, because I've built this now into the top of the boat, like that, with all of the gear on it attached to the top, it's going to be practically impossible to use servos in the watertight cylinder to connect to them. There's plenty of room here, I can do other things, so I'm not even going to think about that. I'm just going to have wires that are going to run to them from the watertight container, and they're going to be fairly long so that I can take the top off. So the question is, where do I put the servos? And I'm not worrying about that right now. As you can tell from what I've built so far, I've got an arm that's sticking out like that, which means that the servo probably should be sitting like that and pulling and pushing it. That's a possibility. What I'll have to do before I mount the servo is get it working with the radio and make sure it's mechanically moving the right way before I put it in. Otherwise I could be in trouble. But we'll get there. I'm not worried about that right now, and I'm not worried about where the servo goes for the other one either. This problem's got to be solved piece by piece. What we need to do is, now that we've got the hull looking like that, we've got the plane on here like that, we've got to connect this to this contraption in here so that it pulls it in. Now, as you can tell just looking at that, if this is a rotating thing, as it will be, because I'm not going to put some kind of hydraulic contraption up there, then this is going to move this arm in that direction or that direction. Plus, when this moves up, it's going to turn as well. So this is all a bit of a nightmare, and I think the only way of resolving that is going to be to put a ball joint on here and a ball joint on there. And as you can see here, I think a small ball joint, standard one, I can glue into that and it will be fine. And once it's in, of course, I won't be moving it again, but that's fine. That doesn't matter. So I've got the ball joint in there that'll move a bit. The next thing to do is to put the thing together once again, get the hydroplane at the angle I want it to be to start with, just get a bit of rod attached to this, going nowhere, mark it where it goes into the hull, pull it up and mark it again, and then I've got the distance, the amount of travel I have to achieve inside the hull. Then I can do some geometry, just on paper, you know, and work out where this is going to have to go and get some gears that are going to fit. That's going to be interesting. God, it's a real challenge, this thing.